So far we discussed about weight of objects near the surface of the earth or on earth, right? In this particular exercise, what we will do in order to understand more about weight, I'm going to do one very special thing, which is basically walk you through what happens to the weight of an object when it is measured on the moon. Okay, so consider this astronaut. Okay, this astronaut is on the moon, and we need to calculate the weight of this astronaut. Okay, now we know weight of an object does change as we go from place to place. It's gonna be different on Earth, it's gonna be different on moon or the sun, right? But the mass is not. Okay, now the weight of an object on the moon would be the force with the moon is attracting that object. So moon was going to attract this astronaut downward, as we know, with some kind of force. Let's say W, F, let's say F. So, and that force is going to be the weight of that astronaut on the moon. Okay. Now from the universal law of gravitation, we know W or F, which is same here, is going to be gravitational constant, capital G, mass of moon, let's say mass of moon is capital M, and I'm gonna use small m here just to make sure we don't confuse it with Earth, and mass of the astronaut, which is going to be small m. Okay, I'm gonna use small m here, and divided by the radius of the moon square. Let's say the radius of this moon is R. And again, you know, this is assuming that the surface, the astronaut is near the surface of the moon. So the separation between the astronaut and the moon surface is not really big compared to the radius of the moon. Okay. So similarly, I can write that this would be the weight of the object on moon, right? The weight of an object on object here is astronaut on the earth is going to be capital G, mass of the earth, which is ME, mass of the astronaut will remain the same, and radius of the earth squared. So radius of the earth is, let's say, RE. Okay, now if I want to find the relationship between the two weights, which is one is on moon, one is on earth, I'm going to take the ratio of it. So I'm going to use a diff. All right. So now let's try to calculate the weight of this object on the moon. Okay. So if I want to calculate the weight of this object on the moon, which we know is Gm of moon, small m, which is of mass of the astronaut, and then radius of the moon. So some of the numbers here, radius of the moon is around 1.74 into 10 to power 6, while the radius of earth is going to be around 6.37 into 10 to power 6. So these units are in meter. Okay. Mass of the moon is about 7.36 into 10 to the power 22 kg, and mass of earth is about 5.98 into 10 to power 24. So mass of the earth is much higher than the mass of moon, which we all know. So if I put these numbers in, so I put the value of mass of moon, radius of moon, I get weight on the moon is about 2.43 into 10 to the power 10, and I'm not putting the value of G at this moment. Okay, let's keep it G, and mass of the object, which is, we know, is not changing. Similarly, I can calculate weight of the object on earth is going to be about 1.474 into 10 to the power 11 capital G multiplied by M, small m. Now the reason I'm keeping these two values still because these are constant. The G is constant, and mass of an astronaut is not going to change whether he is on moon or earth. Okay, so if I just take a ratio of these two numbers, so Wm by We, I get 2.43 into 10 to power 10 G and M, right? And divided by 1.474 into 10 to the power 11 capital G M. Okay, so if I calculated it further, I get Wm by We is roughly equal to 1 upon 6. Okay, so what it is telling me is approximately We by 6. So the weight of this astronaut on moon is 1/6. So if the weight is, let's say, 100 Newton here, that's a big number, but 100 Newton. So the weight here would be 100 by 6 Newton. And that is, we kind of expected it because mass of the moon is small. So the weight or the force with which the moon is going to pull the astronaut would be small. So let's do a problem just to make sure we understand this better. The question is saying that the object weighs 10 Newton when measured on the surface of Earth. What would be its weight when it's measured on the surface of moon? So we know the weight of the object on the Earth is 10 Newton, and it is asking us the weight of the object on moon. Okay, this is the what we have to find. It's going to be in Newton. We know from our previous exercise Wm is approximately We by 6. So I can say 10 by 6 Newton. I can calculate this, something comes about 1.67 Newton, and that would be the weight of the object on the moon. So Wm is 1.67 Newton on the moon. Okay, so the weight of object on the moon is smaller than the weight of the object on Earth. So if we recap the lecture so far, we have studied that the difference between weight and mass is like mass is constant, it's not changing, while weight is basically the force with which it is attracted. In conventional sense, we talked about the weight on Earth, so the force with which the object is attracted towards the Earth, so that would be here. And the second point we discussed about is the weight of an object on moon is smaller than weight of an object on Earth, and that's because the mass of the moon is smaller, the gravitational force on the moon is smaller, and that is causing the weight to also be lesser than the weight on Earth.